Imagine if we wanted to test whether a coin were biased or fair. To do this, we could do an experiment. We could flip the coin a large number of times and record how many times we get heads. We would then divide this by the total number of times we did the experiment, the number of flips or the number of trials. If the coin is fair, we should get roughly 0.5 because we would expect half the time to get heads. The number of times you flip the coin is the number of trials, and the number of times it lands on heads is the frequency. We call the experimental probability or the relative frequency what you get when you divide the frequency by the number of trials. In general, the more trials you do, the closer this will be to the true probability of the event. So the true probability of getting heads on this coin is going to be approximated best if you have a large number of trials. Here is an example. A spinner is spun. The spinner can land on 1, 2, 3, 4, or 5. Student suspects that the spinner is biased, so does an experiment. She spins the spinner and records its result. She does this 100 times and tabulates her results as shown. We want to calculate the relative frequency of each score and state whether the spinner is likely to be biased, giving a reason for our answer. Score 1 occurred 20 times, so we can say the relative frequency of getting 1 is 20 divided by 100, which is 0.2. The relative frequency of getting 2 is 45 divided by 100, which is 0.45. And we can carry on like this, so the relative frequency of getting a 4 is 0.05. And finally, the relative frequency of getting a 5 is going to be 10 divided by 100, which is 0.1. Now, I would say that this provides some evidence that the spinner is biased, because the probability the spinner lands on 2 is much higher than the probability of it landing on the other scores. So the spinner is likely to be biased. If the spinner were fair, the relative frequencies would all be quite similar, which represents the fact that the probabilities of it landing on each of the different numbers should be the same. Here's a question for you to have a go at. Please pause the video now and try it, and when you're ready for the answers, press play. Here are the answers. Given that the relative frequency of getting red is much higher than the relative frequency for the other colours, I would estimate that the spinner is likely to be biased towards red. These are GCSE questions, quite challenging. Please pause the video now if you'd like to try it, and when you're ready to go through the answers, press play. Here are the answers. Red occurred twice as many times as yellow. So to complete the table, I could just notice that the ratio of red to yellow is 2 to 1. So what I could do is work out, first of all, how many times the other colours appear. So the other colours appear 7, 8 and 20 times. So that means that red and yellow must appear 15 times. That means that we have 2 to 1 ratio for red to yellow. So we basically want to share 15 into the ratio 2 to 1. If we do this, we can do 15 divided by 3, which is 5. 5 times 2 for red is going to be 10, and 5 times 1 for yellow is 5. For B, we want to write down the best estimate for the following probabilities on a single spin. You must express your answers as a decimal. For the probability of obtaining black, I've simply worked out that I've got black appears 8 times out of a total of 50 trials. So the relative frequency is 8 divided by 50, which is 0.16, which I could do by changing the fraction here into a decimal. I could basically times the bottom by 2 and the top by 2 to give me 16 hundredths, which is 0.16. This is the relative frequency of obtaining black, which is always a good estimate for the probability of. For this, I've worked out that there are 30 trials where white does not appear, 50 take away 20, and then I've just done 30 divided by 50, which is 0.6. And this is the relative frequency of not obtaining white, which is a good estimate for the probability of not obtaining white.